Hello, my dear friends. Today we are going to discuss about the flywheel. A flywheel is used in machines such as a reservoir, which stores the energy during the period when the supply of energy is more than the requirement, and releases it during the period when the requirement of energy is more than the supply. The flywheel controls the speed variations caused by the fluctuation of engine turning movement during each cycle of operation. In this lecture, mainly we are going to focus on the derivation of energy stored in a flywheel. When a flywheel absorbs the energy, its speed increases, and when it gives up energy, then its speed decreases. Let small m is equals to mass of the flywheel, k radius of gyration, I mass moment of inertia, n1 and n2 maximum and minimum speeds, omega 1 and omega 2 maximum and minimum angular speeds during the cycle in a radian per second, and mean speed capital N, and mean angular speed is represented by the omega, which is equals to omega 1 plus omega 2 divided by 2. This is the coefficient of fluctuation of speed, which is represented by Cs. And we have already discussed this coefficient of fluctuation of speed in previous lecture. So now we know that the mean kinetic energy of the flywheel, that means E is equals to half I omega square. And we know that I is equals to mass moment of inertia, which is value of I, that is equals to mk square. And we know that the maximum fluctuation of energy delta E, that is equals to maximum energy minus minimum energy, or we can say that it is the difference between the maximum and minimum energies. So this is the kinetic energy of, and in this case the mass moment of inertia is constant and the speed is varying, that is maximum speed and minimum speed. For the maximum speed, the kinetic energy is equals to half I omega 1. Omega 1 is the maximum speed, half I omega 1 square, and this is for minimum speed, that is omega 2. And then now we have to solve this equation, and we will have the value of maximum fluctuation of energy delta E, or we can say that energy is stored in the flywheel. So now delta E is equals to half I omega 1 square minus omega 2 square. So open this formula by A1 square minus V1 square. That means omega 1 plus omega 2 and omega 1 minus omega 2. This is omega 1 plus omega 2, and this one is omega 1 minus omega 2. And now you can see here, this is the mean speed, omega 1 plus omega 2 divided by 2, which is represented by omega. In this case, this is the mean speed, and now I mean speed omega 1 plus omega 2 divided by 2, and omega 1 minus k omega 2. And we know that what Cs is equals to omega 1 minus omega 2 divided by omega, or we can say that it is the ratio of difference of maximum and minimum speed to the mean speed. Here you can see that we have multiplied by the omega and divided by the omega. So this one is the multiplied by omega, that means the omega is square, and divided by omega, that means omega 1 minus omega 2 upon omega. So now delta E is equals to half I omega square Cs, and the value of I is equals to mk square omega square Cs. So this is the final derivation of energy stored in the flywheel. Thank you very much.